Welcome back to The Explainer. Today we're focusing on something literally every medical coder needs to master: vascular coding precision. If you've ever found yourself completely tangled up in the rules of catheter selectivity, well, you're absolutely in the right place. We're going to break down the anatomical logic step by step so you never miss a question on this topic again. So get ready, because we're making this complex topic perfectly clear.
Okay, let's dive into this. Here's the exact scenario we're looking at. When a catheter is moved from the aorta into the celiac artery, what degree of selectivity is this? This is a classic exam-style question, and honestly, it's the perfect mystery for us to solve today. Because to assign the right medical code, we have to know exactly where that catheter is going, and crucially, how many turns it took to get there.
But before we look at our multiple choice options, let's establish our foundation. Selectivity is defined as the process of navigating a catheter from a main vessel into a specific branching vessel. Now, I want you to think of this like a giant family tree. The aorta, that's the massive main trunk of our tree. Every single time we turn off that trunk and venture into a new branch, we're increasing our level of selectivity. Our primary job as coders is to figure out exactly which branch level we're hitting.
Let's evaluate our first possible answer. Option A is non-selective. The baseline definition here is actually surprisingly simple. Non-selective just means the catheter stays right there in the main vessel. So in our specific scenario, that would mean the catheter enters the aorta and simply anchors in the aorta, the trunk of our tree, without turning into any smaller side branches at all. It hasn't selected a specific pathway yet. In coding terms, if the physician documents that the catheter was introduced into the aorta, did its diagnostic thing, and never advanced into a branching vessel, you're looking at a non-selective code. It's the absolute starting line of our anatomical journey.
Moving right along to option B, first-order selection. This means we're making our very first deliberate turn. A first-order selection implies moving the catheter into a vessel that branches directly off that main trunk. It's the immediate next step away from the aorta. Just one single turn, and boom, you're there. Think of it as taking the very first exit off a major highway. The second you leave the aorta and enter that immediate branch, you've achieved a first-order selection. You are exactly one step away from the center.
Next up, we've got option C, second-order selection. Logically following our family tree metaphor, a second-order selection requires navigating into a branch that comes off the first branch. So picture it in your head. You've left the main trunk, you've entered the first branch, and then you take another distinct turn into an even smaller branch. That's your second order. You're now two distinct turns away from your starting point in the aorta. Navigating to this point requires quite a bit more precision from the physician, which is exactly why the coding changes to reflect all that additional work.
And finally, we have option D, third-order selection. Simply put, this is a branch of a branch of a branch. This is the deepest level in our list of options. It requires three distinct, completely separate turns away from the main aorta to reach this highly specific vascular destination. By the time a catheter actually reaches a third-order vessel, it is navigated through a complex, winding pathway, moving significantly far away from the initial entry point in the main trunk. Recognizing these three distinct turns in a medical report is absolutely critical for accurate coding.
Let's move to and see how this builds across a clear, logical progression based on our source concepts. Step 1 is the aorta, our non-selective baseline. Step 2 represents any direct branch off the aorta, which gives us our first-order selection. And step 3 is the next branch off of that, taking us to the second order. The crucial point here is knowing exactly where our target vessel, the celiac artery, fits into this whole sequence. Because understanding this hierarchy, that's the master key to vascular coding.
But hey, before we reveal exactly where the celiac artery lives and solve this coding mystery once and for all, I have a super quick request for you. Do you want to truly master medical coding? If you're finding this breakdown helpful, please take just a second to like this explainer and subscribe to my YouTube channel for daily updates. It really, really helps us bring you more of these focused, step-by-step educational guides.
All right, the suspense is over. Let's look back at our full list of options. The correct answer is option B. First-order selection is the absolute winner here. If you guessed B, excellent job. Now, let's look at exactly why this is the case based on the medical rationale from our source material.
Listen to this exact quote directly from the coding rationale. First-order selection means the catheter is moved into a vessel that arises directly from the aorta or vena cava. I want you to heavily emphasize that word directly in your mind. Literally highlight it in your brain. If the branch touches the aorta and the catheter goes straight into it without any intermediate detours whatsoever, you are dealing with a first-order selection.
And this brilliantly illustrates our final conclusion. The anatomy gives us the answer. The celiac artery is one of those major vessels that arises directly from the aorta. Because it branches right off the main trunk with no intermediate turns or intermediate vessels, placing a catheter into it perfectly matches the definition of a first-order selection. There's no guessing required when you just know the anatomy.
So we've successfully conquered the celiac artery, but it certainly isn't the only one branching off that main trunk, right? So I want to leave you with this provocative question to test yourself. How many first-order branches can you identify from the aorta right now? True mastery in vascular coding starts with mastering this anatomy. Keep studying your vascular family trees, and I'll see you in the next explainer.